Okay, welcome back to the second of this week's video. We're going to, you notice I've now in Excel 2003 for those using that format. And let's just quickly recreate the scatter diagram. I'll select the data. I'm going to do insert now in this format and chart. And let's do a scatter diagram XY. No lines, please. And that looks good, so we'll finish. Okay, there's the basic chart. Now, let's add the trend line too while we're thinking about it. I'll click on the data points just like we did before. And I will do add trend line. And we want a linear, but we have to go to options now and ask for the equation on the r squared on the chart. Let's also just say we want to project backwards 12 units. That'll be 1,200 square feet, which ought to take us back beyond zero. Say OK to that, and there's our chart. Just like we did in 2007, only different. Same equation though, and you'll notice now with the projection down to minus 12, I do cross the y-axis at about 48, which is what the equation predicted. So we're looking good. Now the problem 524, which you'll find on page 1324, which you'll find on page 523, asks us to look at the min tab output, which I've immediately have right here for us to examine. And it asks us to find the coefficients of the equation, which we 48 and 5.7 agrees with what we have here. That's good. It also asks us to do what? Find SSE and S on the computer output and report their values. Well, SSE is the sum of the squared errors, and that is the residual error, as they call it here. This is the error that remains after we've accounted for variation due to the trend line, due to the room size, in this home size in this case. And that's this 896.8, which, as you recall, is what we had in the earlier problem. Okay, so that's an S, by the way, is the standard deviation or sample error, which is 10.580. And so we know that. If you're having trouble finding these, incidentally, as the textbook points out, you can look on page 519, and S, you'll see, is look down at the little key down at the bottom is number 8, is the standard error. Okay. Now, part B, C asks us to find SB1 and the T statistic for testing the significance of the slope of the output. Well, the T statistic is equal to, we find on page, where'd it go? Well, page 518 in the shaded area, it's equal to B1, the value of the parameter, divided by SB1. Now, SB1 in MinTab is called the standard error of the coefficient. So this is the standard error not of the prediction, but of the coefficient itself, 0.7457 in this particular case. The coefficient of being 5.7. Now we know that the t value is equal to the value of the coefficient, 5.7, divided by 0.7457. 0.7457. That's 10 point. Whoops, what did I do wrong? 5.7. Sorry, got the wrong answer. Ooh, wouldn't that be awful? Is 7.64 and change. And that's in fact what the t value shows here. Now, in doing a hypothesis test, remember our H0 is that B1 is equal to 0. The status quo is that there's no relationship between x and y. B1 is 0. It just says Y is going to be what it is regardless of the value of the room size. Well, we want to know what's the probability of that, and the t statistic says 7.64 standard deviations away from the mean. We know 7.64 is a lot. HA, I should have completed this, of course, is that B1 is not equal to 0. So if we can't accept B1 is 0, we have to accept that it's not equal to 0. It's either positive or minus. So we have to convert either our alpha values into t values that we can compare to our t here and accept it if it's less than the test statistic. But let's just convert this t statistic into a alpha value, and then we'll know where we stand. Well, it's t inverse of, I always do the wrong one. T distribution of the t value with 10 minus 2 is 8 degrees of freedom, and we need 2 tails because we're doing a not equal to test, just like we've done before. That's 0.6 millionth of a unit. That's pretty small. The probability of 0.6 millionth is awfully small. In fact, you see in the printout here, the t statistic is 7.64. The probability is 0.000. It's nothing. So we can very confidently reject the concept that at virtually any level of alpha that the two are not related. Oh, you couldn't see all that. Oh, darn it. How did I do that? Let me move this down. I think you could probably tell from what I was saying, but here are the numbers. The t value I calculated by dividing 5.7 by the SB1. Here are the hypotheses, and here is the t value. And again, we don't really need to do that calculation because it's all given to us right here. Let's move on and do 13.33, which is on page 523. Same min tab output, and now we're being asked to do what? Oh, wait a minute. 33. I'm sorry, I just gave you the wrong page number. Here we are. 13.33 is on page 530. Now, down at the bottom of this output, we're asked to find the confidence interval. I assume. What's it tell us to do? Repeat, report, and what this output does is to answer these questions. It gives us for a home size of 20, and you can specify these in min tab when you run the report, of a home size of 20, that is 2,000 square feet. We know that the value is 162.03, which is what we had found earlier, and the standard error of the fit is 3.47, which gives us confidence, 95% confidence intervals and prediction intervals of 154 to 170 and 136 to 187. Well, what's this mean? Well, it simply means that the predicted value, let's say you're going out and buy a house. Let's be more specific, and you want a 2,000 square foot house. Well, what you know from this report is that the average 2,000 foot house in whatever area this is has a price that's going to be 95% of the time between $154,000 and $170,000. Well, that's interesting to know. But you say, hey, wait, I'm not buying the average house. I'm buying a particular house. What is the range of individual house prices that I might find? Forget about the average. Well, that's a wider range, as you might expect, 136 to 187, because we don't have the averaging going on. With averaging, you get the house without the swimming pool, the one in the good neighborhood versus the one in the bad neighborhood. You get the one that needs a fixer-upper versus the one that's just been redone with a granite countertops or whatever. That's an average. But the particular house is a wider one because it includes the individual houses, such as the one that needs the new roof without the swimming pool and no granite, as well as the ones that's been fixed up. Okay, that's I'm not asking you to calculate these numbers. Obviously it's a lot of number crunching. What I want you to be able to do is to read a report like a min-tab output, or an Excel output for that matter, and draw conclusions. That's it. I've enjoyed having you in the class this semester. I hope you found these videos useful, and I'll look forward to seeing you perhaps in another class someday. So long.